Okay, so now we want to look at a convex mirror example. So in this case, our convex mirror, that means that the focal point is now on the opposite side of the mirror. So the focal point is going to be negative in a convex mirror, and your center of radius is also going to be negative. So here we can place our object, but it doesn't really matter too much. In all the regions, the behavior of a convex mirror is pretty much the same. But in any case, we want to go ahead and go through this. So if we do this, we want to use our mirror equation. So 1 over dO plus 1 over di is equal to 1 over the focal point. So here, the focal length of the mirror is 10 centimeters, and our object is at 30 centimeters. So the first thing to notice is that our focal length is negative now. So it's convex with a focal length of 10. So that means the true focal length here is negative 10 centimeters. So our object is 1 over 30. It's still positive because it's on the same side of the mirror. And then we want to find what is the distance to the image. So we do our maths on this. So if we rearrange this, I guess we multiply both by 3. So we get negative 3 over 30 minus 1 over 30 is equal to 1 over di. So 1 over di, oops, I'm out of room. 1 over di is equal to negative 2 over 30. So di is equal to negative 15 centimeters. So that means that our image here is virtual. So it's on the other side of the mirror because it's negative. And so that also means that it's upside up. So if we do our magnification, it's negative di over do. So distance to our image is negative 15 divided by 30. So our magnification here is 0.5. So the image is going to be virtual. It's going to look smaller than the object itself. And so you probably noticed this, right? So this is the the convex mirror that you see like in the corner of convenience stores or something, where it can show the whole range of the area. So if you look in that, everything looks smaller. So it's the same thing that's happening here. All right. So next, I'm going to stop this and talk about real images for a bit. Okay, so next we want to talk about the idea of a real versus a virtual image. So the idea is that a virtual image, well, when you look in the mirror, you see a virtual image, right? It looks like there's a person standing on the other side of the mirror, and there's no actual light that is going through that virtual point. So there's an image, but there's no light traveling through that space. It just looks like that's where the light is coming from. In a real image, that means that the light actually crosses and forms an image at a real point in space. And so in the case of our single mirror, we usually run into this. So our virtual images are right side up, and our real images are upside down. But if we're creative, we can create real images that actually look like they're someplace in space. So here I've got my little pig here, and I've put him on top of this funny little device. This video work is really kind of terrible, but the idea is that we are looking at what is a real image. So it appears that that we have our little pig figurine here, and what happens is there's nothing here. So I can move my fingers through it. And the point is that there's no actual object here. It's sort of not really a hologram, but kind of like a hologram. And actually, our piggy is at the bottom of this parabolic mirror. So the reason for that is that basically the light reflects off of these mirrors. It bounces off the top mirror, and then it forms a real image right here where it looks like there is a object. So the concept of a real image can actually produce things that look like it's there. I assume, some of these, when they have a dead entertainer does a concert, they may use some tricks kind of like this, because it does. I don't think it looks quite as good on this crappy camera, but certainly at first glance, it appears that there's some kind of object here. And we turn it, it seems like the object's moving, but it's not a real thing. It's just, a real image that's produced by a mirror. All right, so you have one more question to do on the convex mirrors, so take care of that, and good luck with that last question, and take care of yourself.